We will have Tomas and Javier with us. They are coming from Quix company, Quix AI, and Tomas is the CTO of Quix, and Javier is a senior data science engineer. They will talk about, or they will do an experiment about sentiment, real-time sentiment analysis. And they titled their speech as a most dangerous live demo. So I am very much looking forward what will be here.
Hi everyone, thank you for the introduction. And yes, this is indeed the most dangerous demo ever. Yes, it is a bit of a clickbait title for our presentation, but you will see that it is indeed a dangerous one as we start coding, deploying, and building live whilst asking for your participation. I am Javier Blanco on the left, senior data scientist at Quix. I'm talking to you from Spain today.
I'm Tomas, CTO and co-founder at Quix, and I'm joining you from Prague today.
We want you to participate in our session today, and all you need to do so is your QR readers in your phone. So please make sure you have your phones around for when we start the demo. But before we start the demo, let's do some introductions about Quix first, and then about the concept of streaming. So, Tomas, can you start telling us about Quix since, I mean, you were there from the beginning, right?
Cool, thank you, Javier. Yes, so we founders met in McLaren, and we were building a platform to get telemetry data from F1 cars, and allow engineers in a factory to process them and use techniques like ML and simulations on top of the data. And what we found out that to get 30 million values per minute, that's what you get from one F1 car, to the cloud, and then allow it to be accessible for all people that working on the project, it's quite difficult. And there's a lot of technology to bring together, and actually they are quite intimidating for some engineers. So this is where we saw the opportunity. And so what we try to build as a platform is something that basically allow people to start building projects and products on top of live data from the day one, and they don't have to spend 12 months or more to building in-house solution and then actually build their business logic, and helps with some efficiency and make it a bit easier. So technology like Kafka and Kubernetes and Docker, all of that packaging and maybe a bit nicer package. But before we go further, can you, Javi, talk a bit about streaming and what it actually is, and compare it to batch, for example?
Of course, because yes, as Thomas has been saying, Quix is a streaming data platform. And for those of you who don't know much about streaming in the audience, let's have some quick introduction to what streaming means. And the typical way to present this streaming is actually as opposed to the more traditional batch. So let's think of data flowing as that river over there. Under the batch processing approach, a set of data is collected over time, and then it is fed into an analytics system. So in our water metaphor, you are filling a bucket of water, and then once it's full, drop it into your static place where you're going to that water, or let's go back to data and leave the water there. What we mean is that you collect a batch of information and then you send it for processing. Under the streaming processing approach, data is fed into the analytics tools piece by piece. So you build a pipeline between the river and your lake. That is, you don't need to collect a batch of information and then send it in for processing. You just do the processing one by one, piece by piece, and that means you do it in real time. Check this loading plus aggregation operation that we see here. You can see how with the streaming, we can save a whole step. And this has implications both in speed and computational resources. So batch processing may work well, but only in situations where you don't benefit from real-time analytics results, and also when dealing with batches of data is not too costly, computationally speaking. Let's see a bigger example. I used to work at a telecom company, and the data infrastructure there followed a traditional batch approach. So during the day, different types of information will accumulate in different systems, in different databases. New calls will accumulate in the calls database, and so on. Then at night, the data engineering team had created jobs that will load all that data into the single data lake, where we had all the historic static data, and that was built in layers. So there would be a layer for building, another one for aggregation, and different processing layers. As a data scientist, my machine learning model to predict, for instance, client churn, will be one of those processing layers. And as you can see, it will use last day information to generate the next day's score. And this is one of the problems of batch. We are introducing certain delay between the data generation and our data processes. If the telecom company was following a streaming approach, the data could be processed in real time. There will be a topic for calls where new calls event data will pop in every time there was a new event, and similar for the other topics. And on the other side, there will be a third processing topic where our machine learning will live, listening to the other three, so that every time there was a new event, every time the customer made a new call or we have new internet data, we could update their churn score. So streaming will allow us to react much faster. And I've been talking about topics, so let me introduce you to the basic elements of a streaming infrastructure. And topics are the number one. It is the place where the data is shared. So it is the pipe in our previous water metaphor. And then at one side of the topic, there is a party publishing data into the topic. This producer party writes data into the broker or topic, where it stays available for consumption for a while, and then it just disappears. This is not a database that persists all the data, has many functionalities, but it's not conceived for permanent persistence. Then at the other side of the topic, there will be another party subscribing to the topic, that is consuming the data that is available on the topic. And another key characteristic of topics and streaming systems is that they are asynchronous. It doesn't really matter how many producers or how many subscribers they are, it works. It doesn't matter which rate the writing or the listening is happening, because some buffering systems allow everything to work. So great, you all know a bit now. You all know a bit about streaming. Let's build the demo, Tomas.
Thank you, Javi. So I'm gonna share my screen. Hopefully that's gonna work. Can you see my screen, Javi?
Yes.
Yeah, cool. Thank you. So let's look at our workspace here. We have a chat app already. So we have a simple front end that's implementing chat rooms where you can have a discussion. If you want to do it at home, you just go to library and search for chat app, and you can deploy it to your workspace. Now I'm going to open this application, which is running in Kubernetes, and I'm going to enter a demo room, and I'm going to join it as a Tomas. Now, if you can please now join me in the discussion here and scan this QR code with your phone and just send me some message so we can have a chat here. So I would say, hi all, how are you? So we have a Javi in the chat.
Yep, just one thing, sorry, there is a small delay between the live streaming and the real time, so please anticipate that.
Okay.
About half a minute.
Okay, so I'm gonna wait another minute to everybody to have a chance to join. Oh, we have Elena, Tommy, very cool. Katja, Orsi, amazing. So we have the data. Now, what you're looking at right now is nothing really super complicated. It's the web application that sending data to the topic as an event. Now, I'm gonna now build a transformation that will help me to measure sentiment in a room. Are you discussing in a negative or positive tone? Are you negative about the topic? And I'm gonna try to do it in a scalable, real-time way. So I'm not gonna introduce delay, and hopefully we can scale this to more messages and more people. So I'm gonna click to add new transformation, and I'm gonna use Hugging Face model for sentiment analysis. Normally, you would train your model on history data. So you would go just to database and look at the messages here and label them and build your model. But we don't have a time for that. So let's use existing train model from Google. We have Hugging Face library item here. So if you search for Hugging Face, you will find it here. But to have some fun today, let's do it from scratch. So I'm gonna use the empty template, and I'm gonna listen to messages, which is where you sending me messages from your app, from your phones, and I'm gonna output it to sentiment. And I'm gonna call it sentiment analysis. This will give me a Git project with the template Python code, so I can use it. And before everything, let's just test that we have a connection. Now, normally you can clone it to your IDE with the Git, but today I'm just going to use this web-powered IDE. So I got all the pip dependencies installed, and here I have a code. So just let's run it to see if we are connected. Oh, hello, we have your messages, more messages. Amazing, thank you. So I'm gonna stop it, and I'm gonna add first our Hugging Face library. So in the requirement, I'm gonna use transformers here, and when I save it, I will download this big package here. So when it's happening, Javier, can you talk about what Hugging Face models are?
Sure. For those of you who haven't heard of Hugging Face is a great place of reference, especially around the NLP area. So if that is a field of interest, you should definitely go there and check, because they have benchmark references both in terms of databases where you can bring your own models and compare with other benchmark models, and also these models already pre-trained. And what we are doing here is we are downloading their transformers library, the Python library, and because these big deep learning models are built on PyTorch or on TensorFlow, we have to select one of those libraries to download as well. And that's what is happening right there. It has just finished, and we are ready to go, Thomas.
Cool. So I have the library, and I will now, first of all, import it to my project. So from transformers import pipeline, and then I would load into memory this artifact that will give me English sentiment analysis. There's many of them that you can use, but I'm going to use this one today. And then I'm just going to pass it to my function so I can use it. Cool. That's it. Just to explain what the function actually is here and what this file represents. Quix SDK manage a stream context for you. So each room in this chat application is one stream, and I'm going to take care of each room independently in this function. So I don't have to manage the messages from different chats. So here I would just import again, transformers, our pipeline, and yeah, extend the constructor. So what we are doing here? Well, we are receiving data from topic. We are calling artifacts from transformers to get a score, all in memory, and all using Kafka and all the technologies behind to get our reliability and scalability. And then we're just gonna send it to another topic that the front-end application is subscribing to. So here we remember it, and then every time we receive the event, first we're gonna create a prediction and call our pipeline. So this will get the message and immediately, without any delay, any buffering, any batch, just ask, is it negative or positive sentiment? And then it is we have a two column there. First of all is label. Label is telling us, is this negative or positive prediction? So that, and then we have actual score, which is like how confident we are with this. Now, because we want to do some nice graphs, I'm gonna do this small mathematical transformation. So if we have a negative sentiment, I will just make this little thing here. You will see soon why I'm doing this. Cool. And well, let's print it. If we are actually on something. And let's try it. So because I'm running this for the first time, I'll download the artifact. Next time it will not happen. It will be cached. Cool. So we're getting data. I would stop it. And cool. So you see -1. There's lots of messages. So it's a bit hard to read. Yeah, but it's working. So let's print it back to. I'm getting some feedback that it might be hard to read, so I'm going to make it a bit bigger. So now, how to get it to your application? Well, that's where a Quix SDK comes into place. It's a library in Python that makes it easier to read and write from and to Kafka broker. So here I'm going to just create an event. And I'm going to pass the tags, where is your name, etc. And then I will add a column with the actual message. So nothing new here. This is the message you have sent. Then I will add a column called sentiment. I'm going to actually pass the score. And what will be also nice if we measure every sentiment across the whole room from all people. And because we have this function that represents our stream, it's as easy as just introducing two variables, sum and count. And every time I receive a message, I will just update sum like that and count as well. And then here, I will add another column, which is called average sentiment. And I will just do self sum divided by count to get average sentiment in the room. And that's it. So now I'm going to run it. And Cool, it's running. Now, if I refresh this browser, and I think I have to change back the consumer group because I'm getting the data from previous previous demonstration. Cool, I have a typo, that's fine. I'm gonna fix it here. I have to say this is why it's called the most dangerous demo. So I think I'm gonna change this to second and give it a try. So sum and count is equal, and yeah, I see it. So let's try without this. I'm getting some helps here. Have you tried to start type error and no savings here? Now this is pretty embarrassing, but I don't really see what is the problem. I'm gonna try to cut this for now. Just see if we get the score. Can you please, yeah, so this is working. So we are in business here.
Tomas, maybe you need to send it as parameter data and not events.
Oh, thank you.
Buffer. Yeah.
Thank you.
I couldn't find it, sorry.
Cool, so that's gonna be the problem. Amazing. So if we go to our application, now we see a green and red messages, and we see on the right sentiment. So if you can please send me some messages, hi, ugly, amazing. You see that the average sentiment is being measured. Now, this is cool, but it doesn't really represent the scale. So for that reason, we have another piece here we want to show you. So what we're looking right now is a phone that's sending messages to sentiment analysis code, and then we're sending back in the sentiment topic to your phone. But what if we connect to Twitter and get the Twitter messages into your chat? So let's do that. If we go to Quix and we add a new data source.
With Tomas, we can deploy the sentiment analysis in between.
Yes, but maybe because we have a little time, let's not do that. So here we just need a token. If you want to do it at home, just get to dev.twitter.com and get your token. Just be careful because you have some quota for free account that you might run out if you subscribe for Bitcoin. Lots of people actually talking about Bitcoin. And now we are now subscribing for all the tweets out there in the world that talk about Bitcoin. And there we are, we're getting data. And because obviously it's a different schema that our messages in our chat, we also need to transform that into our messages in our application. So again, we're going to create a new transformation here and just do that. So this is going to be called Twitter to chat transformation. And we're going to listen to Twitter data and output it to messages. So basically the same topic that you guys sending me messages from your phones. And yeah, let's give it a try first to see in what format the messages are being streamed. And in the meantime, I would just disable the bridge so we don't run out of free quota in the middle. Cool. So here, let's just run it and see in what format Twitter is sending it. Cool. So we see here that the message from from Twitter is in a field text. So that's gonna be easy here. Let's stop this and let's. So we're gonna get a text which is in row in parameters called text, and then I'm just gonna output it to output stream as an event. This is where the confusion comes. I was thinking ahead, and this time we need to give it some name. So let's call this mysterious participant in our chat Twitter. And let's just add the value chat message here. So we're gonna get text. So if we run this, cool. And now if we go here to Bitcoin, and again, you can join me with the same QR code system, and we start the Twitter again. In a second, we will see a flow of messages. Actually, we will not until I call this stream Bitcoin. So Bitcoin. Cool. Let's go back. Yeah, I think I'm getting some messages from you guys. And now we have a Bitcoin. And you can see that on the right that we have processed lots of messages per second. And yet it's on a less than 1 core of CPU. And that's because we're using Kafka in memory, no APIs, no Spark in the middle, no JVM. So it's pretty efficient. And if we get more messages that this service can't handle it, we can just scale it using Kubernetes instance, multiple replicas in here. So if I go, for example, to this service and I just stop it and tag it with version 1, I can deploy it to Kubernetes like that. And here, put more replica to actually scale the processing, and it will automatically redistribute the load over the cluster. And yes, so this is how you move it to production, and then you can look at the data lineage, monitoring, CPU, logs, etc. So now you see that this piece of data is being built. So Javi, I'm not sure how much time we have actually. No, we are on time. So can you please talk about use cases where this is all useful and how it's applicable as well?
Sure. So I'll share my screen back if you can stop yours. Good. Great. So I hope you've enjoyed the demo, even with a bit of drama there, but everything went fine. Let's see now other use cases where streaming is key. One of them is the mobility industry, because obviously a mobility company would want to track and optimize their fleet in real time. There's also finance and fintech. The clearest case is fraud detection and loan application acceptance. That's something where banks want to react in real time. But really, pretty much every industry, the gaming industry, media and entertainment, telecommunications, e-commerce, the industry is going into streaming. And by now, you probably guessed why, but these 3 steps are a nice way to summarize it. Actually, these 3 steps are done by McKinsey in some of their annual reports on data. And the first one is that with streaming, the value of your data is the biggest. And this is because the data value decreases over the time that it takes to actuate on it. So with the streaming, we are actuating with the very last value available. And apart from that, we react very fast because streaming systems have very low latency. But also they are very efficient. So with streaming, we save cost compared to database approaches, since we are saving read, load, and storing operations all over the project. However, it is only now that the industry is actually going into streaming. So why is that? Traditionally, people tend to think they don't have streaming data where every single piece of data is created in real time. There's also this misconception we've already treated that streaming is expensive, but especially up to now, streaming was considered too complex. So the Uber, Bookings, LinkedIn, Netflix, Levis, Goldman Sachs, and so on, the big companies with big pockets will create their own data engineering teams to build their own streaming solutions. But I hope we've shown you today that you don't need a data department to build a streaming architecture anymore. So if you want to try it yourselves, my marketing colleagues have prepared this nice bonus for those of you who want to sign up today. As you can see, it has double free credits, and with that, you should be able to build any streaming project for free. So make sure you use your QR reader there one last time today. And that's it from us. We hope you've enjoyed this talk. We just cannot wait to see your streaming projects. Thank you.
Thank you, everyone. Bye-bye. So do we have any questions from
Yes, thank you very much. So that's what I was just going to say. That thank you very much for the presentations. And we are entering the question session. But first of all, I don't know if you recognize this. So I think this should be Javi.
Oh my God, that's me. Can I have that?
Small gift from the organizers and of course
Amazing. I love it. Thank you.
You will get this posted to you. So thank you.
Oh, that's amazing. Thank you. Thank you.
Thank you very much for being with us. And now we are entering the question and answer session. And also I would like to encourage the people, listeners, the audience to answer the poll as well. So in the question and answer session, we will select the most popular ones. So please also use the like buttons to indicate so. Let me just check. First question is from Jeffrey. Jeffrey Westling is asking, in your demo, how is the model determining what is positive and what is negative? Apologies for the novice level. Additionally, is there any merit in testing accuracy? For example, that the messages are being appropriately understood as positive or negative.
Well, that's part of how the model training has been designed. As Thomas was saying, we didn't focus on the training part today. We used a model trained by another party. This is one of the beauties of Hugging Face, as we were saying earlier. You can just go there and use benchmark pre-trained models. So we don't have the details of how that one was trained, but this is, as you could see there, a binary classification problem. So what these transformers models are normally about is about taking into account not just the words and their level, but also their context. So it takes into account the order of the words, it takes into account the actual words. It is quite complex. It is one of the rising deep learning fields of our time. So if you are curious about that, we encourage you to look into it. But we weren't specialized in this bit. We didn't do that model training. We put that model into production as you just saw.
Mm-hmm. So you say that the model actually could be also switched to another one, which might end up in a...
Exactly. We've shown you today what it is, a very efficient, very capable and fast MLOps app. What the model is about is not the main thing in our demo, although it is quite a fun one, this one. Mm-hmm. Yes, we have many use cases with many different models. Our solution is flexible in that way.
Mm-hmm. Yeah, thank you. Let's take the next question, and that is coming from Kata. Kata Horos is asking, what are the potential disadvantages, drawbacks of streaming compared to batch processing beyond complexity?
The complexity is the main one. Second one is that there's a bit of a mindset switch that you have to do to develop streaming applications because data are in flight. We are trying to help with all those tools to make it a bit easier, but data are not basically database available to query in your processing engine. They're coming from broker live. But there are some techniques that can reduce that by things like replaying your data in a loop, so you can develop on top of them. And more importantly, having a setup where you can look at input and outputs to do that. Then I don't see much of a disadvantages, except maybe that infrastructure is different and you need a different skill set compared to batch to set up an infrastructure.
Mm-hmm. Okay. Thank you very much for the answer, and thank you very much for the good presentation and also the live demo. I think the live demo is always something exciting. I guess your blood pressure was also not on the minimum level during the demo. And I can tell you, I think the audience was also excited at the end of the day, seeing the results and seeing how easy it is to integrate a model to a complete system within really, let's say, tens of minutes. That's really a good thing. And I always really like the tech talks, when we are doing really diving deep in the stuff. The video is available online, so some of the listeners have been complaining that the characters were too small, but I guess watching on a bigger screen later on could help this. Thank you very much once again for the presentation, Javier and Tomas, and wish you a good day. Please stay with us if you can. There is a chat session in the main stage. There is a networking session in the break, so you are very much welcome to comment and discuss with the audience. Thank you.
Thank you very much, Benedict.